Guys, welcome to another video on first order linear differential equation. In this video we are going to be solving this kind of problem. If you have any problem that is subject to an initial condition, that problem is called an initial value problem. Okay, now let's solve this problem. Solution: our equation is x squared y prime plus xy equals 1, right? Remember, this y prime is the same thing as dy over dx. Okay, now if you look at this equation, this is a first order linear differential equation. Okay, now before we solve this equation, we need to compare this equation with the standard form of a first order linear differential equation. Recall that with the video I shared with you, the standard form of a first order linear differential equation is given by y prime plus p of x y is equal to what? Q of x. Okay, this p of x is actually the coefficient of y in the equation, and then the q of x is actually what is at the right hand side, right? Now if you look at this equation 1, let me call this out equation 1. If you look at equation 1, it is not yet in this form because there is a coefficient of y prime here which is not in this form. So we need to rescale, or we need to what? Make some manipulation to reduce this equation to the exact form of this first order linear differential. Okay, now let's do that. From equation 1, I have x squared y prime plus xy equals 1. I want to have only y prime here. That means I will eliminate this by dividing through of the equation by x squared. Okay, so this means I'm saying x over x squared. If you divide through by x squared, this x squared, you cancel this x here 1 and x here what? X. Okay, so this equation become, let me bring it up here for easy understanding. Okay, now this equation become y prime, right, plus what? 1 over x y is equal to 1 over x squared, right? This is our new equation. Now this equation has been reduced in this form now, right? So the next thing we are going to do is to compare the equation with the what? Standard form of a first order linear differential equation. So we need to compare this equation here with y prime plus what? P of x, y equals to q of what? X. Comparing these two equations, you can see that p of x is a function of x, which is the coefficient here, and then q of x is what is here, right? So we need to have an integrating factor that can be able to help us solve this equation. So we say let I equal to exponential integral of p x dx be what? An integrating factor. Okay, right? An integrating factor. Now remember, this p of x here is the coefficient of y here. Now if you compare these two equations with this, we have our p of x is equal to what? 1 over x, right? And then our q of x is actually equal to 1 over x what? Square, right? That's very good. Now to get the integrating factor, that means we need to integrate p of x. This implies that our I is equal to exponential integral. Instead of p of x here, we are putting what? 1 over x, right? Dx, right? Remember, the integral of 1 over x dx is ln x. Okay, so this is equal to exponential ln what? X. Now another thing from the theory of logarithm and exponential, this exponential will cancel this ln. You are left with only what? X. Okay, therefore our integrating factor I is equal to what? X. Okay, now the next step is that we are going to multiply the integrating factor. We'll multiply this equation by the integrating factor. Okay, we'll multiply this equation with the integrating factor I. Okay, now let me clean this. Now this is I. Multiply this equation by the integrating factor x. This implies that we are going to get x prime plus what? X over x y is equal to what? X over x square, right? Remember, this one will cancels. We are having x y prime plus what? Y is equal to what? X will cancel here, 1 over what? X, right? Now if you look at this one, the left hand side is actually the derivative of xy, because if you differentiate this rule, you are going to get this. Okay, so we're going to this equal to what? 1 over x. Remember, it is y that we want to find, so we need to integrate this in our y. This implies that integrating both sides, you have integral of d over dx of what? Xy is equal to 1 over what? X. Okay, now this quantity here, the integral of a derivative is that what? Function. So this will cancel out to get what? Xy is equal to integral of 1 over x, actually ln x plus a what? Constant, call it k. This k means the constant of integration. Because it's a definite integral. Remember, when integrating an indefinite integral, you must put the constant of integration. Okay, so this is a constant of integration. Y, the subject is that my y x, right, is equal to ln x over x plus what? K over what? X. Okay, this is the of that equation, but remember, it is subject to an initial condition. Y of 1 is equal to what? 2. So we need to substitute for this our what? This is the constant of integration. Okay, now let's go. Remember, the solution is y of x equals to ln x over x plus k over x, right? But remember, y of 1 is equal to 2. That means y of 1 means that when x is 1, we are having the solution equal to 1. This implies y of 1, substituting here, is equal to ln, wherever you see x, put 1 over 1 plus what? K over what is equal to 2. Right? Now remember, this one is ln 1 plus this one is k equals to 2. Right? Our aim is to be able to get, right? Implies that making k the same, the k is equal to 2 ln 1. But remember, 1 is 0. Okay, this implies that your k, which is equal to 2. Now substitute to give us the full solution. We are going to get x is equal to x over x plus over this general differential equation, right? You can see the more constant obtained here. So the word the general. Thank you very much, guys. Watching, and I, see you guys. I guys to subscribe to my YouTube for more solution on this. Thank you, guys. See you next time. Bye.